Hi there, the Math Dog here. So in this video, I'm going to do some basic translations of words, sentences, phrases, and paragraphs into mathematical expressions and equations. And I plan to do another video with some practice problems that are based on the examples that I've done in this video. So this could be actually for high school, but also could be for middle school as well. So let's get started. So first, we're going to be comparing addition, subtraction, multiplication, division here. So first, let's start with addition. So addition, some phrases, words that you might come across that would mean adding things would be put things together. When you have a tax, you're going to be tacking that on or adding it on. The word combined, total of, sum, increased by, plus, more. Those are all words that suggest you're going to be using addition. So let's do some examples here. Okay, so we have first, I have Jim worked out 20 minutes before school. He worked out X minutes more after school. Write an equation where Y represents the total minutes Jim worked out. Okay, so we're putting two things together here. The word more is a key word here, so we could write Y equals 20 plus X, and that 20 plus X will be the total minutes that Jim worked out, and total again suggests addition. Next example, Janice spent $17.50 on shoes, $34.20 on shirts, and X dollars on jeans. Write an equation where Y represents the combined total Janice spent. So Y equals the sum of all these things. So again, we have the word total. Okay, so that would suggest addition. So we have 17.50 plus 34.20 plus X. And that would be an equation that represents this paragraph or word problem. Okay, last example. A car sells for $25,000 with tax. Taxes are tacked on. If the tax on the car is 10%, what is the price before tax? Okay, so this is with tax. So what we're doing here is we have the original price. That's the price before tax. Original price plus tax is going to equal $25,000. Okay, so I'm going to call the original price, I'll just call it P. Okay, so the original price of the car is, well, I'll show you a couple ways this. One way is, okay, so P, the tax is 10% of the price, so that's going to be 10% of P equals 25,000. So 10% of is multiplication. We haven't gotten to that yet, but 10% is, as a decimal, 0.1 or 0.10. I'm going to write 0.1, so that's 0.1p. This is p plus 0.1p equals $25,000. Remember that one, there's a coefficient of 1 in front of p there, so that's going to be 1p plus 0.1p. So 1 plus 0.1 is be 1.1. So 1.1p is going to equal $25,000. That's our equation. Now, the way I actually like to do this is as follows. So the 100% is the full original price. I'm tacking on a 10% tax. So that's 110%. Okay. Remember what a percentage means. 110% by definition, a percentage is a fraction with 100 as its denominator. So that's going to be 110 over 100. So to write it as a decimal, the 100 is 10 times 10. So every time I divide by 10, I move a decimal point 2 places to the left. So this is 1.10 as a decimal, or just 1.1. So again, the quick method, if you have a percentage to get to a decimal, you simply move the decimal point 2 places to the left. But the reason is because a percentage is a fraction over 100, and every time you divide by 10, you're moving a decimal point 1 place to the left. So since you're dividing by 100, that's moving it 2 places, because you're doing divide by 10, divide by 10. So I can write this then as 1.1. So now I could just go, okay, 1.1p is equal to 25,000. And in this video, we're not going to solve that. Okay. Okay, now let's look at subtraction. So the word discount means you're going to be taking something off of, say, a price. So the phrase less than suggests subtraction, decreased by suggests subtraction, reduced by suggests subtraction, difference means subtraction, take away, and minus. So let's do some examples here. So let y represent the difference. Okay, there, right there, that means subtraction of x and 16. Write an equation representing the statement. So I'll write y equals x minus 16. Suppose you another example. Suppose you currently have m marbles in a bag. You take away, that's subtract x marbles. Write an equation using t to represent the marbles remaining in the bag. So t is going to be the original number of marbles you have, m, minus x. Okay, next, so let's write an expression for 6 less than a number n. Okay, so less than here suggests subtraction. Less than a number. Okay. So we start with n, and we're taking 6 away from it, so that's going to be n minus 6. Okay, and then my last example for subtraction. A shirt that normally sells for $30 is marked at 25% off. What is the sale price? So I start at 100%, okay? I'm taking 25% away from 100%, leaving me with 75% of the original price. Now, as I mentioned a minute ago, what does 75% mean as a fraction? Well, that means 75 over 100, because a percentage is a fraction with 100 in the denominator. Okay, well, to make a decimal, remember this is 75 over 10 times 10, and every time you divide by 10, you're moving a decimal point 1 place to the left, so this is going to be dividing by 10 twice, so as a decimal, that's 0.75. Again, you don't want to have to go through this. You just need to memorize that to go from percent to decimal, you need to move the decimal point 2 places to the left. So this is equal to 0.75. So the sale price, if I let PS equal the sale price, and it's going to, P is the original price, I let S equal the sale price. Sale price is going to be 0.75 times P. Right, now let's take a look at multiplication. So some terms that suggest multiplication are product. The product of two numbers is multiplication. The product of 3 and 4 is 3 times 4. Reduced by some fraction or percentage suggests multiplication. Increased by a fraction or percentage suggests multiplication. Doubled, tripled, halved, etc. is multiplication. The word of, whenever you see the word of, that almost always means multiplication. And stretched or shrunk by some scale factor. Okay, scale factor is a magnification or a shrinkage. Okay, so like if I double something, if I have magnification factor of 2x, the scale factor is 2. If I shrink something in half, the scale factor is 1/2. 1/2 of the original. Okay, so let's do some examples. The length of the car is x feet. A model of the car is 1/40th the length of the actual car. So that is going to be a shrink, and the word of the model is going to be 1/40th the length of the actual car. Write an equation where y is the length of the model car. Well, that's going to be y equals 1/40th of is times x. Notice you can also write this as y equals x over 40. I think it's actually more useful to write it this way than this first way, but either one is correct. Alright, so the next question. So the tax on a motorcycle is 8% of means times. Here is almost always means equals. So this is key information here, and also I haven't emphasized enough that you need to be sure to figure out what are you actually trying to find in the problem. And it takes time. It's worth it sometimes, oftentimes, to write out the problem before you put in symbols. So right here, the tax on a motorcycle is 8% of the price of the motorcycle. Okay, so the price of the motorcycle we'll call P. That's the original price. The tax is $100, okay? So we know the tax is $100. So 8% of the price has to be 100. That's the key to this problem. Let P equal the original price before tax. Okay, so I know that 8%, so this is what I mean by writing out. I know 8% of P has to equal 100, because that's what it says. Okay, that should be 8. It is 8, but it's a very bad 8. Okay, so now that's 0.08. Of means times. I could put a dot in there. P equals 100. That's the equation. Now, I don't have to put that dot in there, because if I write 0.08 P, that means 0.08 times P equals 100. And this is how you usually want to write this. So if we solve that equation for P, we would find the original price. That's not what we're doing here. We're just setting up the expressions and equations. So next, write an expression for the product of a number n and 5. So you could write n times 5, but preferably we usually like to write 5n. Okay, 5n means 5 times n. Literally it means n added to itself 5 times, but we have multiplication, so we don't have to write this out. It's just easier to write 5n rather than having to write n added to itself 5 times. So 5 is called, here, this is called the coefficient, and n is a variable. N is a variable because I can change its value. So coefficient, C-O-E-F-F-I-C-I-E-N-T. Okay, the last example here. Suppose a bag of marbles have 4 times more red marbles than white marbles. Okay, if x represents the number of white marbles, write an equation where y represents the number of red marbles. Okay, so we know that x equals number of white marbles. So we have 4 times more red. So 4 times x will be the number of red marbles. Alright, so we're going to write an equation where y represents the number of red marbles. Well, that's just going to be y equals 4x. Okay? And finally, we look at division. So division is breaking into parts. How many times into something? The ratio of, a ratio is like 4/5, which we could write also as 4 to 5 this way. We could say 4 to 5 this way. So that's another thing we probably should say, something to something. Why? That means division. This fraction bar means division. And we could also write this 4 to 5. So ratio implies division. It's a fraction. Ratio of per, so miles per hour, for example. When you see it on a speed limit sign, you see mph, but in math and science, we can write that as miles, mi for miles, per hour. So per means divided by. Okay, and then quotient. Quotient is the result of a division problem. That's the answer to a division problem. So an example, 1/2 of a watermelon is split evenly among X people. Okay, if Y is the amount of watermelon each person gets, write an equation for Y. So we want to know how many times X goes into 1/2. So this is going to be Y equals 1/2 divided by X. Okay, and we'll just leave it like that for now. All right. So second, a car travels 80 miles in X hours. Okay, write a ratio. Ratio suggests something to something. That's division. That gives the average. That's called the average or mean speed of the car over the X hour period. So that's going to be 80 over X. That's 80 miles per X hours. 80 is in miles, X is in hours, and that's going to be miles per hour. Okay, our last example, a pitcher is 3/4 full of water, okay? Suppose a serving is 1/8 of the pitcher. How many servings are there? Well, this is going to be a division problem, but I'm going to illustrate this first using a cylindrical pitcher. Imagine you have a cylinder here. Okay, so it's 3/4 full, so I'm going to break this up into fourths. So we got, there's fourths. Okay, imagine these are all equal slices. Okay, so it's 3/4 full of water. So let's fill it with water. Okay, so there's 3/4 full. Now, serving is 1/8 of the pitcher, so a serving, I'm going to use red here. I could divide each of those fourths in half, and now I have 8/8. So 3/4, how many servings are there? Well, there's going to be, a serving is the red section, so there's 1, 2, 3, 4, 5, 6. So the answer is going to be 6. So the problem is going to be set up as 3/4. How many times does 1/8 go into 3/4? I'm actually going to do this one. I've done a video on division of fractions. So if you recall from division of fractions, when you divide fractions, you change the division to multiplication, and then you go take the reciprocal of 1/8, which is flipping it upside down. Well, that's going to be 24 over 4, but that is 6. Okay? So this concludes this video. If you found this video informative and you liked it, please give it a thumbs up. And please consider subscribing to my YouTube channel, The Math Dog. You may share the content of this video with others. Thank you and have a good day.